Hi, I'm Sarah Meerow. I'm a professor in the School of Geographical Sciences and Urban Planning here at Arizona State University, and today I'm going to talk to you about resilience in the context of global change. In today's lecture, I'll start out by explaining why resilience has become so popular in recent years. Then I'll introduce some of the key concepts that you need to understand in order to really understand resilience theory and explain some of the opportunities and challenges for actually applying resilience in policy and practice. By the end of this lecture, you should be able to explain why resilience is an important concept, an increasingly popular one, define some of the key resilience concepts, particularly ecological resilience concepts, and discuss some of these challenges and opportunities for resilience policy as we move forward and grapple with global change. So let's first talk a little bit about why resilience has become popular. Well, it has now been widely declared that we have entered the Anthropocene, a new geologic epoch in which humans are the driving force of planetary change. Since the Industrial Revolution, global human activity and its impacts on Earth's natural systems have increased exponentially in what has been termed the Great Acceleration. As you can see in these graphs here, for example, the rapid rise of human population and water use correspond to changes in carbon emissions, forest loss, and more. As we, as a global society, try to think about how to deal with the Great Acceleration and to deal with global change, we've sort of coalesced around this idea of sustainable development over the last several decades. Sustainable development was famously defined by the Brundtland Commission in 1987 as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So sustainable development is really focused on balancing current economic growth and development with environmental conservation for present and future generations, as well as enhanced equity. It recognizes the need to balance economic concerns and development with the environment as well as social justice. And in particular, it draws our attention to the importance of intergenerational equity and thinking about the future and how to preserve resources and opportunities for those future generations. Overall, sustainability and the idea of sustainable development have been very influential for decades and have really made an important contribution in dealing with global change. But sustainable development, as it's traditionally been conceived, does have some important limitations. Well, first of all, if we think about that Brundtland definition, it sort of assumes that we can predict the needs of future generations because we're going to be preserving them. But can we? Could people, for instance, have predicted our needs 100 or 200 years ago? I'm not so sure. It also tries to maintain or sustain ecological stability, typically. But, as we'll discuss in a bit, research suggests that complex systems, which involve both human and natural components, things like cities or infrastructure, have multiple stable states and are constantly evolving. And also, sustainable development has typically, in terms of management, has typically focused on finding maximum sustainable yields, which are based on a fixed rate that has been determined to be sustainable or allowed or able to be maintained into the future. So, for example, it determines how many fish you can catch without depleting the population beyond a point which you won't have enough fish in the future. But given rapid global change, there is a question of whether these kinds of yields are going to maintain constant over time, and how do we actually think about adjusting or adapting them potentially as systems change. And in fact, I think if you look at all of the changes that are happening around the world, both social and environmental, everything from population growth, diminishing resources, climate change, technological advancements and change, changing geopolitics and economic characteristics, it doesn't really look like a particularly stable or predictable world as we think about the future. And it it does seem that we really need to expect the unexpected as we plan for the future. And ultimately, this is really what resilience is about. It's about expecting that the unexpected will occur and trying to focus resources and energy on preparing for or enhancing the capacity to adapt to whatever sort of stress or changes come your way. More specifically, resilience can be defined as the capacity of a system to absorb or withstand perturbations, so this is some kind of disruption or disturbance, as well as other stressors, so those are kind of shocks and more slow stressors, such that the system will remain within the same regime, or in other words, that it'll have the same basic structure and function. And we'll talk a little bit more about this definition later, but ultimately, the important thing to remember is resilience, at its core, is about coping with shocks and stressors and about adapting to changes in the future so that you can maintain key functions that you want to preserve. And if we look across the policy and policy discourse in recent years, we've seen a rapid increase in the amount of high impact policy initiatives, plans, conferences, international meetings, etc., that are focused on resilience. Essentially, it seems that there is a growing recognition that we need to expect this unexpected and that we need to focus on becoming more resilient. So let's talk a little bit more about what that means and where this concept of resilience comes from. Well, it should be noted that the word resilience has a long history of use in different disciplines. It's been used for many decades in the field of psychology to think about how, for example, children cope with traumatic experiences and how they're able to be resilient to those and continue to live normal and happy lives. It's been used in engineering to talk about how quickly a system can bounce back to a previous equilibrium or how much disturbance or pressure it can maintain without breaking. And so this is an important, I think, distinction to understand is engineering resilience focuses on how quickly a system can bounce back to a particular equilibrium. So let's think of a popular sort of metaphor that's used in the resilience scholarship, and that's this idea of a ball and cup here. So here we have a cup, and you can see that from an engineering resilience perspective, this cup could represent, represents a system. Resilience in the engineering concept is about if you push that ball up, you put pressure on it, or you fill it with water, how long would it take before the ball would return back to its normal resting equilibrium, which is down there at the bottom? In contrast, in the field of ecology, resilience has generally been defined as how much disturbance, how much pressure a system can take before moving into another state. So in this conception, it assumes that resilience, that their systems don't just have one state that they're in and that where there's equilibrium, but there are different ones. And resilience is about how much, so it doesn't matter necessarily how the system changes within the cup. So it can move around in there, it can change a little bit, but resilience is about how much change it can take before it would cross a threshold and go into a completely different state. And I'll provide some more practical examples of that in a second, but I just want to first introduce these two concepts between engineering and ecological resilience. And when we talk about resilience in the context of global change, we're generally talking about either ecological resilience or social ecological resilience, which again, I'll talk about in a minute. But even social ecological resilience draws more on this ecological concept than on the engineering resilience concept. And when we talk about ecological resilience, it is generally attributed to the scholar Buzz Holling, who you can see in this picture here, And he wrote a seminal article in 1973 in which he identified that ecosystems actually do have these multiple stable states because they're complex adaptive systems, and that resilience was the persistence of the relationships within a system. So that means it's staying within, using our metaphor, within that cup, and how much of change it could absorb, how much pressure it could take before it would flip out of it and into a completely different state and system, so into that second cup there. And it should be noted that once it's in another state, it's often difficult to move it back. So, as I mentioned, Halling suggested that ecosystems are examples of complex adaptive systems. And this is a concept that you'll hear a lot in the resilience work, complex adaptive systems. It draws on theories of complexity, which I want to point out are different than ideas of complicated systems. So a complex system or a complex adaptive system is one in which there are a small set of critical processes that create and maintain the self-organization of the system. What differentiates, a key property that differentiates a complex and a complicated system is that a complex system has emergent properties, which means that the whole is greater than the sum of the parts. Or in other words, if you know all of the different components, you still cannot necessarily predict what you will get when you combine all of them together. That novelty is called emergence, and that is something that differentiates complex systems. And sort of a classic example of a complex adaptive system is a city. If we think about all of the different components of a city, you could separate them out, but when you put them all together, it ends up being something that's novel and different potentially than you could have imagined. It would be very hard to predict what a city would be like just based on any of the individual components. Now, I wanted to, as promised, provide a couple examples from the real world of these resilience concepts. So again, up top, we can see some of our ball and cup example here. And then below it, we have both an ecological example and an urban system example. So we can think about the idea of those multiple stable states. Here we have these two cups or basins. We have a threshold. And so if this was a healthy natural ecosystem, it would be a grass ecosystem that is relatively resilient. And what we mean by that is you can see that the basin is fairly deep. So that means that it can take quite a bit of pressure or movement before it would flip over the threshold and into a radically different one. Alternatively, if we're thinking about the urban system, this could be a well-managed city that's resilient, but it's important to note that while it's functioning well now in both cases, if you erode the resilience, so you make that basin lower, then it becomes degraded, and then it's easier for the system to cross a threshold that you don't want and become, get fixed into a very undesirable state. So in the grassland example, if it's degraded due to overgrazing or a prolonged drought, then it's going to become really easy to shift over. And when that happens, when you've lost all of your resilience, then you can see that the ball just easily crosses that threshold quickly, and it suddenly becomes a desert. Or if you're talking about an urban system, it might experience a sudden large-scale strife or violence or protest, or have a population crash where lots of people suddenly leave. And then now it's in an alternative state. And here we can see that this second state has a lot of resilience, but it's an undesirable resilience in this case. So we can see here in this state that you could actually have systems that are quite resilient, but undesirable. So if you think about this desert, it's going to be difficult to return it back to its prior grassland state. Or in the city, it has, say, high crime rates and cycles of poverty in it, etc. And when Just to point out, when you have these shifts and this loss of resilience and moves into another stable state, that's what's called in the ecological resilience literature a regime shift. And now I want to talk about a third type of resilience, which I alluded to earlier, which is the idea of social ecological, or what's sometimes called evolutionary resilience. So just to recap, we've talked about engineering resilience, ecological resilience. Now we're talking about social ecological, or evolutionary resilience. So this is based on the idea that in the Anthropocene, most systems have human and natural components, or are what are called social and ecological systems. And these SESs, social ecological systems, generally don't actually have equilibrium. It's argued they're complex systems that are constantly evolving. And SES resilience is about the capacity of these systems to adapt to changes, which are inevitable because they're constantly evolving, or to increase adaptive capacity, and is about maintaining key functions. But importantly, it's not about necessarily staying the same, because that would be impossible in these constantly evolving systems. And in fact, resilience is often seen here as about bouncing forward. So this is recognizing, so if we think about engineering resilience as was about bouncing back to a prior state, social ecological resilience is about actually bouncing forward. So you're thinking about the fact it's saying that it's not going to be possible to bounce back to a previous state or even desirable, and instead you're trying to move into a preferred or more desirable state after a disruption. You're trying to evolve. And in fact, social ecological resilience scholars have made the case that social ecological systems, a wide range of them, actually go through similar cycles of which are called, and they term this the adaptive cycle, which you can see here, which has four components or four stages, and that systems are basically constantly moving through these. These include the growth or exploitation phase, the conservation phase, a collapse or release phase, and then reorganization. And it is argued that depending on which of these phases that you're in or stages, that you have a different amounts of resilience in them. So I want to provide a real-world example, thinking about how you might adapt or you might apply the adaptive cycle to thinking about a city over time. So let's think about the city of Detroit. Many of you are probably aware about some of the challenges that this city has gone through. So we can think about we'll start off with the 1950s, the exploitation phase. In which case, or in the early 1900s, when the city was in the exploitation phase, here we could see that Detroit was growing very rapidly. It was developing. The automobile industry was just taking off. There was a lot of growth in that, but and here there was quite a lot of resilience in that it was a diverse economy. There was a lot of rapid innovation and development and change. But over time, as we reached the middle of the 20th century, the city became less diverse in terms of its economy. It became really, really focused and specialized on the automobile industry. And it started to be a little less flexible and more rigid. And as a result, then, when there were a couple of shocks in the 1960s, both including race riots, but also economic shocks in the latter part of the 20th century, the city was unable to adapt well to that. And so it essentially went through kind of a period of collapse where it lost a huge amount of its population. It actually the city went bankrupt. And now you could argue that it's potentially entering a phase of reorganization, where the city is rethinking about its future, coming up with new visions for how it'll develop, how to use its vacant land, for example. This is one project which was trying to rethink the city because it has a much smaller population than it used to. It has as much as 30 to 40% of the land is vacant in the city, and so they're trying to think about how they could maybe redevelop into a much greener city by using some of that vacant land to develop green spaces and consolidating it. So in this way, in this stage, there's potentially a lot of resilience, a lot of potential, but it's unclear exactly how it'll ultimately reorganize and restructure itself. And so again, this idea of the adaptive cycle has been applied to many different systems, including economic, ecosystems, etc. And of course, it is an oversimplification in some ways of these complex systems, but it can be useful for thinking through resilience and trying to understand where a system is in its development course over time, and thinking about how these complex systems evolve and change. Now, to further complicate things, the resilience scholars have argued that these adaptive cycles do not just happen at one scale, but actually happen at nested scales. So if you really want to understand resilience of a system, you have to think about not just, say, the city of Detroit, but you have to think about the city of Detroit as embedded within a larger region, and as also made up of smaller neighborhoods, and even those neighborhoods made up of parcels. And that those different scales actually influence each other and shape how these ultimately these stages and cycles and resilience. So for example, this idea of panarchy, where you have these nested adaptive cycles, you have sort of two key mechanisms. You have remember, which argues that as systems, or as these adaptive cycles at smaller scales are changing over time, they are in some ways sort of conserved, or they draw on institutional memory and other conservation things, or their radical innovation can be checked by what's happening at larger scales. So if you think about this, and the larger scale can actually help to also add resilience or help it from radically transforming or moving into another stable state. So if you think about a neighborhood, if you had a neighborhood which was undergoing some kind of radical transformation or protest, you could have a larger city policy that would actually help to support that system, add backup, say, or reduce some of that radical change and provide sort of that memory. Alternatively, things that happen at smaller scales can also lead to revolt at larger scales. So in other words, you could have, say, a city program that helps, you could have a pilot project at a small scale, which is so successful that it ends up influencing citywide policies. And so in this way, what's sort of radical changes at a small scale can lead to increased resilience across the city scale and ultimately change and shape those adaptation processes and evolution over time. So I know this has been a bit more theoretical. I just want to quickly recap. So resilience at its heart says that we need to expect the unexpected. It says that complex systems are always changing. They experience both slow changes as well as rapid shocks, and that changes at one scale can impact resilience at another. And so you need to really think through these different scalar dimensions and also think about how systems are evolving over time. And ultimately, the future is uncertain, so a focus on building adaptive capacity to manage this uncertainty is really what resilience is all about.